Hey y'all, it's Miss Escamilla here, and today we're going to be learning about altitudes and perpendicular bisectors. So first we're going to go over an altitude. And an altitude is a segment that goes from a vertex that is perpendicular to the other side, or the line containing the opposite side. So it creates a right angle right here. There's a 90-degree angle on this side and a 90-degree angle on this side. Another word that we could use for altitude that we'll use later in geometry is going to be height. So basically it's telling you how tall the triangle is. And what this means is that altitudes, again, go through a vertex and they create those 90-degree angles. So how you might see a question based off of this is you're given a triangle. You're told HA is an altitude of HJK. Find X, the measure of HAJ, and JK. Well, we know that it's an altitude, so we know that we have a 90-degree angle right here and a 90-degree angle right here. We don't know anything about those two side lengths, but we do know that 3x plus 3 gives us a 90-degree angle. So we say 3x plus 3 equals 90 degrees. And this is an equation we can use to now solve for x. If you subtract 3, you get 3x equals 87. Divide by 3, you get x equals 29. So I've now solved for x. I know the measure of HAJ was a 90-degree angle, so I've solved for that as well. And now it wants us to solve for JK. JK is JA plus AK. JA is x plus 8, or 29 plus 8, so 37. AK is x minus 9, or 29 minus 9, so 20. And JK will give us 57. So I've now solved for all three things this problem is asking for. Again, the biggest thing we need to remember is that an altitude creates 90-degree angles. So look at your angle and set that equation equal to 90. Next, we have a perpendicular bisector. And a perpendicular bisector is, by definition, pretty self-explanatory. It's going to be perpendicular, and it's going to bisect. So what that means is you get two 90-degree angles right here and two equal sides right here. With perpendicular bisectors, when they overlap, where they meet in the middle, that is called the circumcenter. And the circumcenter, the only thing you need to know about it is that it's equidistant from the three vertices. So this is the circumcenter right here. It is the same distance from this vertex, and this vertex. All equidistant, all the same distance. There will not be numerical questions about this. You just need to know that as a fact that the circumcenter, which is where the perpendicular bisectors meet, is equidistant from all three of the vertices. And then lastly, you have the perpendicular bisector theorem, which is in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant, it is the same distance from the endpoints of the segment. And therefore, if the point is equidistant, then it's on the perpendicular bisector. And you're like, okay, cool. What does this look like? So two ways you might see it. AD is the perpendicular bisector of BC. Find X. Well, we know it's bisected, so we know this is congruent to that. If they're congruent, we know we can set them equal. So we have x plus 5 is equal to 3x minus 5. We can set the equation up like this because we know the two sides are congruent. They are bisected, they are therefore congruent. If I move the x's to the right side, I get 5 equals 2x minus 5. Move the 5 to the left side, 10 equals 2x, divide by 2, and you get x equals 5. Again, perpendicular bisector means we're going to bisect, we're going to cut into two equal pieces. The pieces are equal, you set them equal to each other. To practice the perpendicular bisector theorem, all right, this looks like an altitude because there's the right angle, but we know it's more specifically a perpendicular bisector because this is cut into two equal pieces, which means we know that those two sides fulfill the perpendicular bisector theorem. We're going to set them equal to each other. So we're going to say 5x minus 1 is equal to 7x minus 15. I'm going to move the 7x to the left side. 5 minus 7 is negative 2x minus 1 equals negative 15. Add 1 to both sides. I get negative 2x equals negative 14. Divide both sides by negative 2 and you get x equals 7. If you had to solve for the side lengths, remember that we would plug that x back in. We would get 5 times 7 minus 1, which is 34. We would get 7 times 7 minus 15, which also gives us 34. And that's a good way to check. You saw that 34 equals 34, and that's exactly what we wanted to do. We said they needed to be equal to each other. So that is all for today. Let me know if you have any questions.